Hi everybody, thank you for watching my video on physics. In this video, I would like to give my answers to the two questions which I have asked in the previous video. At the same time, I would like to clarify some misconceptions on states of matter. My first question is, what are the differences between the mist above the dry ice and the mist above the hot drinks? I have noticed that some students said incorrectly that the mist above the dry ice are carbon dioxide. I think I need to talk more about carbon dioxide to clarify the concepts. At room temperature and standard atmospheric pressure, carbon dioxide is a gas. Almost all gases are invisible, including water vapor, carbon dioxide, and air, because individual gas molecules are too small to reflect light. Remember that objects visible to us are either liquid or solid. Therefore, the mist above dry ice must either be solid or liquid. Let me explain how the mist above a dry ice is formed. As dry ice sublimates, carbon dioxide gas leaves the solid. It is a cold stream of gas and is invisible. Since it is cold, it will cause the water vapor in air to condense. As a result, tiny water drops are formed along the path of the carbon dioxide gas. Since carbon dioxide is heavier than air, it sinks. On the other hand, cold air sinks. Therefore, the mist above a dry ice does not move up. Instead, it moves downward and is bound to the ground. This is different from steam, which always moves up. When water boils, the steam is hot, less dense than air, and vice versa. Again, I need to emphasize that steam is invisible because individual water molecules do not reflect light. As the hot vapor meets the cold air, it is cooled, condenses into liquid water, and produces visible white mist. Unlike the mist above dry ice, the mist above hot drinks rises due to rising air current. Let's summarize the differences between the mist above dry ice and hot drinks. Firstly, their movements are different. The mist above a dry ice sinks, but the mist above a hot drink rises. Secondly, their sources are different. The mist above a dry ice is condensed from water vapor in air. The mist above a hot drink is condensed from hot water vapor, which is evaporated from the drink itself. On the other hand, they have the following similarities. Firstly, they are both water droplets. They are not water vapors nor carbon dioxide. Secondly, they are resulted from condensation of water vapor when the water vapor is cooled. For those above a dry ice, the water vapor in air is cooled by the cold carbon dioxide gas. For those above a hot drink, the water vapor from the hot drink is cooled by air. My second question asks you to explain why, while mist can be produced by very cold and very hot objects, they do not appear above objects at room temperature. Cold objects can be a dry ice or a frozen fruit taken out of the freezer of a refrigerator. Since air consists of water vapor, when the water vapor is cooled by the cold object, it will condense into tiny water drops. As a result, mist are formed. On the other hand, not all hot objects will produce mist. Only hot objects with water will produce mist. For example, a hot iron bar will not produce any mist, but when water is splashed onto the bar, water will vaporize to form steam. When the steam is cooled, it condenses into water drops. As a result, mists are formed. Objects at room temperature do not produce mist because to produce mist, it requires water vapor to condense into water drops. If an object does not give out hot water vapor, or if it is not cold enough to cause water vapor in air to condense, mist will not be formed. I would like to talk more about carbon dioxide, although it is not strictly required in the syllabus. At room temperature and normal pressure, carbon dioxide is a gas. For example, there are carbon dioxide gas in air. But when cooled to as low as minus 58 degrees Celsius, carbon dioxide gas will solidify directly to form dry ice without passing through the liquid state. This process is called deposition. Look at this experiment. A balloon filled with carbon dioxide gas is immersed into liquid nitrogen at minus 216 degrees Celsius. The balloon shrinks and solid carbon dioxide is formed. On the other hand, if the experiment is repeated using air, you will see liquid air inside the balloon. This shows that it is difficult for carbon dioxide to be liquefied. To liquefy carbon dioxide gas, it requires extremely high pressure. For example, liquid carbon dioxide can only be found inside a fire extinguisher, which has a very strong wall made by thick metal. When released, the carbon dioxide gas will come out quickly. The expansion will cause drop in temperature so that some carbon dioxide gas will turn into dry ice. Carbon dioxide also exists inside a bottle of soft drink. We say that the carbon dioxide gas dissolves into the soft drink. Unlike liquid carbon dioxide inside a fire extinguisher, the carbon dioxide in a soft drink is still a gas. This is similar to oxygen gas dissolved in water, allowing fishes to breathe. When pressure is released or when the bottle is shaken, the dissolved carbon dioxide will form bubbles which will rush out of the bottle quickly, causing the soft drink eruption. Besides shaking the bottle, we can also produce a jet of soft drink by adding Mentos into the bottle. The rough surface of the Mentos causes the dissolved carbon dioxide to form bubble quickly. Alternatively, we can produce soft drink eruption by putting the bottle with the lid open inside an ultrasonic cleaner. In summary, you have learned that mists are formed by condensation of water vapor, whether it is due to a dry ice or a hot drink. You have also learned that mist may rise or sink. It may come from the hot drink itself or the water vapor in air. Concerning carbon dioxide, it is normally a gas, but when it is cooled, it will become a solid. When it is pressurized, it will become a liquid. Question: explain why ultrasonic cleaner can cause soft drink eruption. Be the first to write your answer in the comments below. You are welcome to comment on the answers of other people. I hope this video can help you understand more about mist. Thank you for watching.